So let's start our game development. We are going to use tkinter package. Okay. So import tkinter as tk. Now create a root of our game. So tk.tk, this tk function will give the root. Okay. Give the title to the root, ball and paddle. We'll run and see the impact of this. Now, so consider this root as our wooden stand. Okay, so we don't draw our pictures on wooden stand. We need some paper, sheet of paper to fix on that, or some canvas to fix on that wooden stand, and then we start drawing on that canvas. So create a canvas here. Okay, canvas. So tk.canvas will give you a canvas. So I need a sheet of paper of width 400, height 300, and white colored sheet. Okay, so this will create one canvas for me, and I'm saying that I will fix this canvas on my root on my wooden stand. Okay, so it is created. Now this line canvas dot pack. By this line, I'm fixing this canvas on my wooden stand. Okay, and then I'm creating one paddle rectangle at 150, 280, 250, 290 coordinates x1, y1, x2, y2. We'll discuss this x1, y2, x2, y2 in detail in next presentation. Okay, in few moments. So I'm creating this rectangular paddle of black color here, and I'm creating one default ball here at this location 190, 60, 210, 80 of blue color. Okay, and I'm running this program. See the impact of this. Okay, so this is root. On that root I have created this canvas of white color. Let me make it red color so you'll understand the some difference. For the time being, I'm making it red. Okay, let's run it. So initially root was created, title was ball and paddle. So you can see this title ball and paddle here. Then I have created canvas, and then I have packed this canvas. Okay. As I told you, canvas dot pack is like using Fevicol or hammer and nail to fix this canvas on the wooden stand. If I comment this line, if I don't run this line, you will not see this red color sheet. Let me comment it and run it. Okay, I'm running it. See that canvas is disappeared because I have not fixed it on the stand. So this command is there to make this active. This canvas will become active. So I hope I understood this. Okay, red color. So I don't need red. I'm making it white. Okay, white. Okay, and then this ball is also drawn on the canvas. I'm seeing paddle create rectangle. So rectangle I'm drawing on canvas, and for ball I'm drawing oval shape structure on the canvas. Okay, so this is visible. Now why this coordinates? Basically anything which is drawn on the canvas is in the form of rectangle. Let me. So this was my canvas. This was my canvas. I'm drawing ball here. Okay, some ball here, some ball. Yeah, this one. But as I mentioned, this coordinate here, okay, 150, 280, 250, 290. So basically, it's a rectangle, invisible rectangle, something like this. Okay, inside this rectangle, this ball is drawn. Okay, so this is x1, y1, this is x2, y2. So this corner is 150 and 280, x1, y1, and other corner is 250 and 250 and 290. Okay, so we'll discuss this in much detail later. So this is how you need to understand here. Okay. So let's go ahead. Now let's think of moving this paddle first. We'll talk about moving ball later. Ball will move randomly up and down, left and right. Let's start thinking about moving the paddle using arrow keys. So look at this code. There are two functions are defined here. Okay, move left and move right. These are two functions. We have discussed functions in earlier classes, right? So these are the functions someone need to be executed. What is this doing? Canvas dot move. This canvas class which we created here at the top of the code. This one. This canvas class has many methods. Okay, one of the method is move. So when you say canvas dot move, it gets the signal that it has to move. Something has to be moved. What has to be moved? Paddle. Because the paddle we have created and paddle also we have fixed on canvas. Okay. So paddle we have created inside the canvas at this location. So this canvas information that it has a paddle. And now we are saying move minus 20 and here move right plus 20. So if you remember xy coordinate, if you want to move to the left, you have to decrease the x coordinate, okay? And if you want to move to the right, we have to increase the x coordinate. Okay, so this we have created. But now if I run this and if I use arrow keys, pedal is not moving at all. So something is missing. What is that which is missing? Let's see. Let's explore and see what is missing. Okay, friends. So before we go forward, it's good to understand how x and y coordinates are drafted on your screen. Okay. So let me run this and listen what I'm saying. See, look at my mouse cursor. Okay. So my mouse cursor is at this left top corner. So you can see x equal to 0, y equal to 0. Okay, x is 0, y equal to 0. Now when I move towards right, towards my right, x is increasing. Okay, y is constant. Okay, x is increasing. If I move towards left, x is decreasing. See 501, 493, blah 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 blah. It will come till 0. Similarly, my mouse cursor is in the middle of the screen now. If I go down, see y is increasing. So if you go down, y is increasing. Okay. And if you go up, y will decrease. Okay. So suppose you want to move to left in x direction, what you should do? You should decrease the x coordinate. See, whenever you move to left, x coordinate decreases. Now again, I'm at the center. If I want to move to the right, I should increase x coordinate. X1, y1. X1 should be increased. Okay. If I want to move up, y should be constant and x should increase. If I want to move in some angle, x and y both should be increased, right? X and y both. If I want to move straight, only y will increase, x will remain constant, okay? So I'm sure you understood how this works. Based on this, we have already seen how the pedal was moving towards x minus 20. For each key of, for each stroke of left arrow, x was decreasing by minus, and for each stroke of right arrow, x was increasing by 20 coordinates. So I hope it is clear to you. So let me stop this and then we'll go back to the paddle ball game. The missing piece of information is this, these two lines, okay? Now, paddle is there inside the canvas. We have mentioned two user defined functions, move left, move right, and we are saying canvas dot move. Canvas should move paddle by 20 minus or canvas should move paddle by 20 plus. But when? Here I am binding this. Yeah, here I'm binding something to canvas. What I'm saying, hey canvas, I'm binding something to you. What I'm binding? Left. I'm binding left arrow key to you. What I'm saying, hey canvas, whenever user press left arrow key, you should call this function move left. So whenever you press left arrow key, this function will be called. What this function is doing is, if this function is saying, hey canvas, move your pedal by minus 20x. So move the pedal left side by 20 coordinates, 20x coordinate. So it will move left. Similarly for right, okay, move by 20x coordinate, right side plus x coordinate. Now see, let me run this. Now I'm using arrow keys. See, it is moving left arrow, it is moving right arrow. So Tkinter is such a easy package, okay, for beginners. Now you are able to do animation here, right? So you are able to control your objects inside your screen by left and right arrow keys. Okay. Okay, so let's go ahead and see how we can move the ball. Let me stop this. Now let's see. We are moving the ball here. So we need to write a code to move the ball. Controlling pedal. But right now, you should ensure that ball should not cross any boundaries. Okay. Now see, in this case, this ball is touching the left wall, but it is not. It is touching the top, but it is not going beyond top, and it is touching. So left wall, right wall, and top. It should not go beyond that. Okay. So how to control that? That's what we'll see now. So right now we are at this stage. This is our code. This is a code, and currently we are in a position to rotate this paddle, move this paddle around, and ball is stationary, and we need to move the ball. So let's concentrate on moving the ball and do further coding. So let's start. If you look at the code, this is our canvas. What is canvas? It is with width 400 and height 300. Okay. So inside the root TK, we are on the canvas. So it is our canvas. This one is the canvas. And as we have seen earlier, this top right corner, this is x1, y1. So x1 equal to 0 here. Okay. And y1 equal to 0. Y1 equal to 0. And this is x2, y2. This x2 equal to 400 because width is 400. So 0 to 400, right? This direction. From this 0 till 400. This is the width. Okay. Similarly, height is 300. So y1 equal to 0, y2 equal to 300 in downward direction. Okay. So y2 equal to 300. These are the coordinates of our canvas. Okay. And if you look at the code about circle, which circle that you are, the ball circle that we are trying to move now. Okay, this ball. This ball is drawn at this particular position, 190, 60, 210, 80. So basically it is some invisible rectangle, okay? Invisible rectangle. And it has got x1, y1, x1 equal to 190, and y1 equal to 60, x2 equal to 210, 210, and y2 equal to 80. So if you observe this is 20 by 20 rectangle, and inside that there is a circle. Now we need to move this, right? Now please listen very carefully. While we move this ball, suppose we are moving ball started here, and suppose ball is initially moving in this direction, okay, in this direction. So this x2, we should ensure that this x2 should never be more than width of the screen. So it should never be more than 400, okay. Once it reaches to 400, so this ball should keep moving in this direction till x2 is less than or equal to 400. The moment x2 becomes 400, it should start moving in the opposite direction, and it should keep moving in this direction till x1 is greater than or equal to 0. The moment x1 becomes 0, it should stop here. It should not go here. It will not be visible. The moment x1 becomes 0, x1 of this ball rectangle, it should again change the direction. Got it? Similarly, if suppose this ball is going in this fashion, right? Angular fashion. The moment ball reaches here, ball should not go beyond this. Okay. So what we should check? We should check y1. The moment till the time y1 is less than equal to 0, ball should keep moving in upward direction. The moment x1 becomes 0, ball should start moving in downward direction, in this fashion, whatever fashion. Till it should come down till y2 is less than equal to this uh, 300, because height is 300. Okay. The moment y2 becomes 300, ball should start moving upward. Okay. Ball should start moving upward. I hope it is clear. Okay. So let's remember this and let's go forward. And also remember one very important thing. Okay. This x1, y1, x2, y2. Here also x1, y1, x2, y2. In Python, Inter graphics programming, x1 is called as x1 is called as coordinate 0. coordinate 0. Okay. Y1 is coordinate 1. X2 is called as coordinate 2. And Y2 is referred as coordinate 4, coordinate 3. Okay. Remember this. This is very important. Okay. For our future logic. So x1 is called as coordinate 0, y1 is coordinate 1, x2 is called as coordinate 2, and y2 is called as coordinate 3. So let's revisit our code and try to write some functionality for moving the ball. So let's write this user defined function. I have taken two variables, distance x, distance y, dx dy. I have designed this move ball function, dx dy I am going to use, and I am asking canvas to move the ball. So this canvas will move the ball automatically. We don't need to write any extra code. I am asking canvas, hey canvas, move this ball. Every time move it, every time move the ball by uh, two places in x direction and two places in y direction. So it will move in 45-degree angle, something like that. Okay. And then we'll see what is this. And I should keep calling this function move all function after every 20 microseconds. Okay. And as you know, this function is there, function has to be called. Okay. So here I'm calling this function. So this function is getting called once. It is going inside. It is moving the ball by two coordinates in x direction, two coordinates in y direction plus 2 2, and then again after 20 microseconds I'm again calling this function move on. So it will again go here. So it will run in infinite loop as the timing or as of now. Let's run this and see. See, ball is moving now, but it is crossing that side one. We need to control. We have discussed. We need to control that, right? And we have discussed coordinates also. So how to ensure that this ball should not cross this wall, and this top roof. Okay, let's see. So as we have discussed coordinate 1, coordinate 0, coordinate 1, coordinate 2, coordinate 3. You know that, right? X1, Y1, X2, Y2. And we have discussed the condition, how to avoid, how to ensure that ball is not crossing the wall. So I'm writing that code here, okay? I have tested all those conditions. Ball coordinate 0, if coordinate 0, ball is less than equal to 0, or coordinates 2 of ball is greater than equal to 400, I should, this positive direction of dx was 2, so it was moving towards right. I should make it minus. If it is less than 0, then it was minus, it should become plus. So it should keep on moving in either direction. Similarly for this y also, okay? If ball is coordinate x1 of ball, y1 of ball is trying to be less than or equal to 0, I should make this y dy2 equal to minus 2, so that it should come in downward direction. Negative thing is downward direction, positive is upward direction. We have seen that xy coordinate program also. So now let's run this again. Okay, see. Now only thing is it is going below this bottom, because that is our game. We'll ensure that if it goes below that, we'll over the game, we'll end the game. Okay. So let's do that later. Let's do that later. So dear friends, till now we have done this much of functionality. This is the code for this, what we have done till now. You can try to write this code in your PyCharm and run and see the output yourself. Our next target is to bring life to the paddle. So whenever ball touches the paddle, ball should jump up, okay, and then again slowly should start coming down. And we should always, and we will try to use paddle to bounce the ball back. So let's do that. So we need to check here one more functionality. We need to check whether the ball has collided with paddle or not. And before that, remember the coordinates of paddle. See paddle. Paddle x1 equal to 150, y1 equal to 280, x2 equal to 250, y2 equal to 290. So it is very clear that the width of the pedal is from 150 to 250, 100 places, 100 pixels, or for imagination say 100 centimeter. And height of the pedal is 280 to 290, y1 equal to 280, y2 equal to 290. So it's only 10 centimeters or 10 places or 10 pixels. Okay. And I already explained to you. Coordinate 0 is this, coordinate 1 is this, coordinate 2 is this, coordinate 3 is this. Okay. Now it's very, very easy to check the collision logic. Okay. So let's go ahead with that. Okay. So let's understand the collision logic. Now suppose this is a ball. This is a ball which is dropping from somewhere offside. And this is a pedal which you are moving. Okay. And we are trying to touch the ball with paddle so that game should not over and ball should bounce back. So before bouncing the ball back or upward, we should be able to write a logic so that our program should understand that ball is collided with the paddle. Okay, so what is that condition? First condition should be x2. This x2 of the ball rectangle, okay, this x2 should be greater than or equal to this x1, okay, paddle ka x1. This x2 should be greater than or equal to this x1. This is condition 1. Okay. Second condition is this x1 of this ball, okay, x1 of this rectangle should be less than or equal to this x2 of this paddle, okay. This x1 should be less than or equal to x2. If it is more than x2 means it means ball is gone beyond this area, okay, means paddle was not there. Okay, so this is the situation. Third condition should be this y2 of this ball, okay, this y2 of this ball should be greater than equal to y1 of this paddle, okay. This y2 should not be more than this y1, means it means ball is not come here, it means it has not crossed the paddle. That should be the condition. And fourth condition should be y1 of this ball, this y1 of this ball should be less than equal to y2 of this paddle, means again we are checking that ball is not gone beyond this. If these four conditions are true, it means the ball is collided with the paddle, because we are checking these rectangles. Wherever is the position of this rectangle, we are always checking the coordinates because we are passing the coordinates to this function. Now we'll see how we have done this in the coding. Okay. I hope this is clear. Please watch this again and again and understand the coordinates. Okay, so let's start implementing the code for detecting collision between paddle and ball. So I'm writing some function here, collision, check collision. I'm checking all the conditions which we discussed in earlier discussion, all coordinates. To this function, I'm passing coordinates of ball and coordinates of paddle. So I should call this function from somewhere, okay? So if this function is defined here, it has to be called, right? So let's call this function from here. Okay, here. Okay, I'm checking if collision, if this returns true, means if collision happens, what I need to do? I will do, I will simply change the y direction from positive to negative. Ball is coming down, so y was increasing. So once it collides paddle, I will make it minus dy. So dy will become minus 2 now. So it will keep on going in upward direction by two places. Okay. Y will increase 2 every time. Okay. And we have already taken care of the problem where if it collides with upper roof, it will automatically come down. It will be bounced down. Okay. We already discussed that logic. So let's run this code. Okay. What is this? Okay. So let's add this line here. Dx equal to minus dy. Okay. And now run this code. See, it is detecting collision. It is going to the roof and it is coming down from the roof. We have done that part. So this game is almost ready. Ready to play. Only thing I have to control now, this paddle is disappearing. It is going beyond the wall. So we need to do that and that's it. हमारा काम खत्म हो गया भाई. Okay, so let's stop here. Now let's think about controlling the movement of paddle so that this paddle should not go beyond this limit. Currently it is going, okay, it is disappearing also. So what I should do? I should simply to check one thing. I should keep on moving this paddle in this direction till this x1 is less than equal to 0. Okay, when paddle starts moving in this direction, this x1 will decrease by 20 coordinates. You have seen in the code. We'll again revisit the code. So this will x1 will become 170, then sorry 130, then 110, then 90, then 70. At some point in time, it will become 0 or less than. It will try to become less than 0. The moment that situation arises, stop moving the paddle in this direction. Okay, so then you have to forcefully press right key. So from here it will start moving in right direction. It will x2 coordinate will increase by 20, 20, 20, 20 something. And one situation will come where x2 will try to become more bigger than 400. Width is 400. So keep moving this paddle in this direction till x2 is less than equal to 400. The moment it tries to become more than 400 or even if it is equal to 400, stop moving that. Okay, stop responding to the right key. So user has to forcefully press left key. So keep on doing this. Okay, so let's see this in the code how it is done. Okay, so let's do some changes in this code in order to control our paddle so that it should not go beyond those walls in either left or right side. Okay, so simply replace this code with new code, this part. Okay, what I'm doing here every time while moving left or moving right, I'm taking the coordinates of my paddle and I'm checking. Okay, if x1 of my paddle is greater than 0, then only I am moving in the left direction. Okay. The moment it becomes 0, means it touches the wall, this condition will become false. It will not be true. So it will stop moving. Similarly, while moving on right direction, I am checking if x2 of my paddle, okay, if it is 400, I will keep on moving in the right direction. The moment it becomes 400, means I have reached the wall. So I will stop moving. So this way, this will work. Let's run this code. So now everything is under control. Okay. Only thing that we need to take care of now is the moment suppose the moment the ball misses the paddle, ball is missing the paddle. Okay. We are trying to chase the ball, we are not able to chase. Okay. So game should say game is over because ball has not collided with the paddle. So let's see how to do that. Let's stop here. Now let's write a code to close the game and display the message game over once the ball touches the bottom. If ball miss the paddle, it will touch the bottom. Okay, so this is the code here. Okay, if ball chord 3 means y2 of ball, right bottom corner of the wall, y2. Okay, if it becomes greater than or equal to 300 means greater than a height or even equal to the height. It means ball has touched the below boundary, bottom boundary. So create this message, okay? Game over, font Arial 20, red color message at this particular X and Y coordinate on the canvas, okay? And then return statement will be executed. As you know, as all of us know, return will close, return will terminate the running function. So this move all function will stop, which is the main function of our game, okay? So this program will terminate. Let's run. Let it collide with the bottom wall. Game is over, okay? So here we have completed our game. Okay. So I will in next slide I will summarize what we have learned and I will request all of you to keep watching and subscribing my videos and please share this YouTube channel. I need your support and it will encourage me to come up with such kind of contents which will encourage all categories of students, kids, teens or professionals to improve their skills and learn new things. So that's all for the day. Thank you so much. Please watch my next slide where I shared my contact information. Please share this message. Thanks a lot. So this is overall code, total Python code to develop this game. You can slowly go through this code, type it line by line, try to understand each line. If there are any issues, please replay my video and try to understand. If you have any questions, concerns, you can drop my message. I will try to reply. I will surely reply to your messages. So just enjoy the coding.